Okay, so hello everyone. Yes, thank you to coming for coming to this workshop. So what we're going to talk about today is about how we can bring DEX functionality on top of Latin network. This workshop will be divided in three parts. First, I will give you some theoretical understanding of how RGB works, because spoiler alert, we do all of this with RGB. How RGB on top of Lighting works, and how we can achieve atomic swapping functionality on top of Lighting. Then we will show a short demo of a prototype of how this works, and then Gabriele will take the stage and will show the project is working, contributing to for first implementation of this. So yeah, let's start first with the general idea. First a few words about myself. I'm Federico Tenga. I work in Bitfinex. I work specifically in the Bitfinex team that is focused on RGB development. What we're doing in our team is we are just trying to make the RGB ecosystem grow. We don't have any specific business goal yet. We are not working on any products that want to gain market share. We just want the RGB ecosystem to grow. How are we doing this? First of all, we contributing to the protocol itself. So we did several PRs, testing, bug fixing to make the protocol more robust and more reliable. Then we build numerous developers tools. In particular, RGBlib is the main project. It's a library to help developers to easily integrate RGB into a wallet without having to fully understand all the internals of how RGB works, which are quite complex. We released an Iris wallet, RGB compatible wallet for Android, which is called Iris Wallet. If you go on the Play Store, you can find the testnet version of it. We built an RGB compatible Latin node, which is also what we will talk about today, and it's called RGB Latin node. It's available on GitHub, but on the public repository doesn't have already all the features that we will talk about today, but you can already open RGB channels, do payments and do routing with RGB denominated channels. And then we also try to support other teams that are building on top of RGB, especially if they use our libraries. So first, some general idea about RGB. I will try not to waste too much time on this because we have other cool stuff to discuss, but still I think it's important. So RGB employs a very different model compared to all the other blockchain that we know about, and employs the model of client-side validation as opposed to a global ledger. So the difference that in a global ledger, everybody push all the transaction information on a blockchain that everyone can see and everyone needs to validate. And while this has its advantages, it also has its flaw because everybody needs to validate every one transaction. So it's quite it causes some scalability issues, and it's also bad for privacy because everybody sees everyone's transaction. While with the client-side model, everybody only validates the transactions that are relevant for his own wallet, and we only share the data about the transaction with the counterparty that is interested in. So basically, if I do a payment, if I pay you, I will share with you the information about this transaction and all this history that you need to validate, but we will not put it on a global ledger. So, well, then if you want to put it on your website, you can, if you want to be transparent for whatever reason, but by default, the data remains private. And this is if for people that already saw my talk this morning, I already showed it, but still, just a quick recap of how RGB actually works on chain. We first create an issuance contract that defines all the RGB metadata and main information, such as the asset name, asset ticker, total supply, if there is any attachment, any extra rules that are related to this asset, whatever. And then we define who is the first owner of these assets that we just issued. And how do we define an owner? The owner is a Bitcoin UTXO. So in this example, we issued some red tokens, whatever that is, and we assigned all the supply to the UTXO A. This UTXO can be anything. It can be a single sig, multi-sig, very complex script, a Lightning channel, could be a BitVM script, like whatever you want. The only thing that matters is that you prove ownership by spending it. So by the ability to spend the transaction, it means that you are the legitimate owner, whatever are the rules to spend the UTXO. And how do you spend it? You create this concept of ownership transfer, which is not so different from a Bitcoin transaction, where there is an input, so the UTXO that you're spending, or could also be multiple UTXOs, but let's keep it simple. And then as output, the UTXO where you're sending the tokens to. So in this example, the owner, the issuer, had all these 100 token in UTXO A, and is sending 20 token to UTXO B, so likely like his counterparty that he's paying, and 80 token back to UTXO C, which is the change where he's sending back his asset that is doesn't want to send to the counterparty. Because when you spend an UTXO, you need to spend it completely. You cannot just spend part of it. And this ownership transfer is just like a message that encodes these informations. And all of this is committed. So to make it simple, like you make an hash, and actually it's a bit more complicated than that, but let's say that we make an hash of this ownership transfers, and we commit it inside a Bitcoin transaction. But not any Bitcoin transaction. It needs to be the Bitcoin transaction that is spending UTXO A, which was the previous owner of the asset. So in this way, we demonstrated that we are the legitimate owner of the asset by spending the UTXO that at the asset allocation. And we are committing that this is the only ownership transfer we can do. We cannot do it twice, we cannot do double spending. So the rules of RGB are made in such a way that you can only have one valid commitment per transaction. And the commitment goes in one of the outputs of the Bitcoin transaction. And yeah, I don't want to go too much into details on how that works, but this is the general idea that it's important to understand understand how the rest works. And then the next owner then will do the same thing. Now we have some tokens that are allocated to UTXO B, and it will create a transaction that move the token to a new UTXO, and it creates a commitment. Let me just just wanted to make sure that the charger was connected. And so on and so forth. Then you create this chain of transaction that creates the asset history. But yeah, we are all here to discuss about DEX on Lightning, so let's try to figure out how it works, the compatibility with Lightning. It is possible to modify an existing Lightning node to support RGB assets, because what we do is that we just allocate RGB assets to the UTXO of the commitment transactions of Lightning channels. Then we will go more into details in the coming slides. So you can take an existing Lightning node, make some small modification to have extra modularity. In particular, what you will want to have is to have control over the each commitment transaction of the channel updates, because you need to add in each of them the commitment to the RGB state transition. And that's what we did in our team in Bitfinex. We took LDK. We made some small changes just to add more modularity, not to put RGB logic in it. And then with that small forked version of LDK, we created a RGB Lightning node, which also using our library RGB libs has all the RGB logic to create RGB state transitions. Once you have that, you can create asset-denominated Lightning channel. So it will be like normal Lightning channel, but instead of being denominated in Bitcoins, they will be denominated in whatever asset you want to have. So like USDT, other stablecoins, security tokens, or whatever you come out with. The asset then, at this point, once you have a RGB asset-denominated Lightning channel, you can move the asset with the same speed, the convenience that you have with normal Bitcoin Lightning payments, and also with the same flows that you need to be always online, and it's the same model, like with these benefits and this flow. And one of these is that, of course, you need to have liquidity, so you can do routing across channels that have liquidity in the asset you are transferring. And this works exactly like Lightning, same security model, same benefits, and same usability. So now let's go a bit more into details of how this works. So the general idea is that we first send assets to the multi-sync UTXO of a Lightning channel opening. Then for every channel update, we create a new pair of RGB state transitions they send the asset to the output that are created by the Lightning commitment transactions. And then when we close the channel, each party move the asset from the Lightning commitment transaction to UTXO to one that they control exclusively in exclusivity, like they do with Bitcoin on Lightnings. Maybe it's a bit hard to understand like this, so let's go to see how it works more into details. So this part here, this is a normal channel opening, how it works in Bitcoin without introducing RGB. When we introduce RGB, we create a node, a state transition, that moves assets that were allocated to the UTXO, that the input UTXO that we are using for the channel opening. So in this case, the UTXO of Alice, whatever it is. And we create a state transition that says, okay, those 500 USDT that first were allocated to the UTXO of Alice, now will move to the multi-sig UTXO of Alice and Bob. So from now on, this 500 USDT can only be moved if Alice and Bob cosign. And then all of this is anchored in an op-return output that contains the hash of the state transition, but in reality you have a bunch of Merkle trees in the middle. But yeah, it's essentially a hash of the state transition. And in this way, yeah, we effectively opened, we did the first step of the funding RGB denominated Lightning channel. But before you broadcast this, you will want to have the commitment transaction so that both parties are able to close unilaterally. So this part here, this is our normal Lightning commitment transaction for channel update works. And what we add for RGB is just we create a new state transition that moves 500 those 500 USDT that were in the multisig. We move them towards the outputs that are created by the Lightning commitment transaction of the channel update. So this is just like normal Lightning stuff. We have the first output that is contains both the Satoshi and now also the RGB asset that can be taken unilaterally by Alice. And we have the second output where there are two spending conditions. Either Bob can take away both the Satoshi and the USDT after a time lock, or if this was actually an old state of the channel, Alice can take whatever is in the second output by disclosing the secret of Bob of the that it was shared when they updated the channel. So as you can see, we are fully leveraging Lightning security model, and we are just adding allocations to those outputs that are created when you update a Lightning channel. And all of this, as usual, it is committed, is anchored, not to confuse the terminology, is anchored in the in an op-return output that with added to contain the anchor. So in this ways, if this is the commitment transaction that is signed by Alice and owned by Bob. So this is what Bob will use if he wants to unilaterally close the channel. And then, yeah, so if this is actually the last state of the channel, Bob will take his part. If it's not, Alice will take everything, will punish Bob and take everything, both the Bitcoin and the RGB state transition, and the RGB asset, sorry. As you can see, we also have some Satoshis in this. How many Satoshi we need to have in this in each of these transactions? Not much, just a few thousand to manage to be able to produce always produce outputs that are above the dust limit. So if we go on chain, those are outputs that are actually exist on chain and they can be spent and they can be confirmed and then later on spent. So the amount of Satoshi is not proportional in any way to the amount of assets you're moving. It's just a fixed small amount that you just need to create the outputs in case of a settlement on chain. So, and then, yeah, every time we update the channel, we will just update the USDT amount. So the Satoshi amount doesn't need to change because it's not economically relevant. It's just something that we need for technical reasons. And every time we update the channel, we will just update the UTXO amounts in the RGB state transition, and we will replace always the new version with the old version with the new version. And yeah, this is the specular Lightning commitment transaction, which is the one that Bob signed and is controlled by Alice in case she wants to unilaterally close the channel. And this, just specular, just that the first output is what Bob can take unilaterally, and the second one is what Alice can take after the time lock, or Bob can use to punish Alice if this was not the last state of the channel. So then, of course, like in Lightning, we don't only want to have a bilateral bidirectional payment channel. We also want to have routing. So how we do routing? The same way we do it in Lightning. In normal Lightning on Bitcoin, we just add an extra output that also contains that has a three spending condition, either Bob plus the per-image of the payments, Bob with Alice signature. This is the case that is signed by Bob and controlled by Alice, or Alice after the time lock if everything is kind of stuck in the middle. But this is, looks complicated, but this is just like normal Lightning stuff. The only thing that RGB does is to create a state transition with 3 output allocations, and it just allocates it to the 3 outputs of the Lightning commitment transaction. So we just take Lightning as it is, and we add the allocation to the output generated by the Lightning commitment transaction. This is how it works on Lightning, and this is how it works on the RGB Lightning node that we built, and it's already available on GitHub that you can try for yourself. And you can. We don't have yet a user interface, but you can already play around with the node and see how this works then in real life. And if you know how to use Lightning, it will be pretty much the same user experience, same complexity. There is no extra knowledge that you need to have to use this. Then let's go to the interesting part, which is the actual topic of this workshop, which is the how to have a DEX on top of Lightning. So first of all, why we want a DEX on top of Lightning? What are the benefits? The benefits is that once we are able to trade assets, if we can trade assets directly on Lightning, we leverage all the benefits on Lightning not only for payments but also for trading. So first of all, we don't need to pay on-chain fees, which is something that you need to do with AMM on EVM chains. You have very low latency. You have the latency of Lightning. So if you have a direct payment channel, it will be very, very low, probably under 1 second. And if you need to do some routing, it may take a bit more, but potentially very, very low latency. You have no front running because the transactions, the trade remain private, so nobody can see what you're doing and use this information against you. And overall, you have a better, like an atomic swap-based system is a better alternative to liquidity pools that you traditionally have on Ethereum. So the way it works is that we create like a circular payment on Lightning, where it starts, let's say from Alice, it routes the Bitcoin part to Bob, and then Bob routes the Tether part back to Alice. And in this way, basically both Alice and Bob, they are on one side receiving one asset and the other side sending the other asset. And all of this is atomic because it's just like a normal Lightning routed payment. Like on Lightning, the routing nodes, they cannot steal the fund. Also here, no one can steal the funds, including the 2 counterparties. Either everything goes well and is settled, or the payment fails and nobody and the trade just doesn't happen. So there is no counterparty risk. It either goes or it doesn't. So let's go a bit more into details on how the swap mechanism works. So you have first the taker. So this model is based on a taker. You will have a market maker, the quota price, and the taker that accept the price. So first, the taker needs to ask to the maker for a quotation. It says how much how many USDT I need to pay to get 1 Bitcoin, something like this. And the taker will come out with an answer, with a price. So the maker proposes a price, and shares a string that encodes all the swapping condition. So the string says the asset ID that we are exchanging, how many assets you're receiving, how many satoshis you're paying, what is the expiration date. So basic information about the swap. If the taker agrees and he likes it, he will take this string, he will import it in his own Lightning node, and he will add it as a whitelisted. It will whitelist the trade that is being proposed. So with this whitelisting, why do we need it? Is a way to say, okay, if for whatever reason somebody asks me to route a payment that I receive Bitcoin and I send USDT for this exchange rate, then okay, let's approve it. So it's not that the node will accept any request for swapping that they will arrive, because otherwise I can say, oh yeah, here is one USDT, give me one Bitcoin. So the node needs to have an external approval of what is a trade that the user agrees to, and this is achieved through this whitelisting. So the taker knows, whitelist the trade, that says if somebody asks me to do this, I will accept it because my user is okay with it. At this point, then the taker sends a feedback to the maker, say, okay, I'm okay with your quotation. I whitelisted the trade. We can proceed. And at this point, the maker initiates the swap. So he creates like a Lightning payment, but with this swap logic in the middle. And like this swap, it may sound weird, but at the end is really not much difference of what we have normally on Lightning. Because when we do normal Lightning payments, only with Bitcoin Lightning payments, basically what we do is that we get Bitcoin in one channel and we send other Bitcoins on the other channel. But they are different Bitcoins. So we don't call it a swap because we consider the Bitcoin in one channel and the Bitcoin in the other channel to be fungible with each other, to be the same swap, to the same asset. But actually they're like different coins. So the only difference that we're introducing here is that the asset that we receive on one channel and then the asset that we send on the other one, they are not fungible with each other. They have a different price and they are treated differently by the market. So really all of this, the complicated part here is mostly the coordination between the two parts, but then the settlement itself, it doesn't hold much more complexity than a normal Lightning node routed payment. One question that is often asked is regarding the free American call option problem. So it's the problem that you always have with when you try to make some decentralized trading stuff. So first of all, it is impossible to completely eliminate the American free call option for one of the party without introducing third-party coordinators. But when you introduce a third-party coordinators, basically you just give the option, the free call option to this third-party coordinator. So yeah, we could do it, but it's not particularly interesting. If people want to do it, they can, but it doesn't really solve the issue. Yeah, sorry. Yeah, the question is, what is the free call option problem? Yeah, right. Yeah, I skipped on that. So in general in finance, a call option is when I have the right to buy an asset at a given price at some point in the future. And in particular, the American call option are made that you can exercise this option to buy an asset at a given price at any point until the expiry date. So a call option can be you have the right to buy Bitcoin at $30,000 between now and the end of October. Something like this can be a call option. And what does it mean? So if the price stays at 29, the option is not really valuable because you have the option, you have the possibility to buy at 30,000, which is above the market price. So you wouldn't want to do that. If you want to buy Bitcoin, you will just buy a market price at 29. But if Bitcoin goes at 31, 33, 40, 50K, then it's very cool. It's a very good opportunity to have that you can buy Bitcoin at 30K when the price is 50K. And so this option has a value because it can be, there is a possibility that will be very, very valuable in the future. So if the Bitcoin goes to 50K, then the option to buy at 30K is basically $20,000 of value. And the problem is that if we give, if one of the party has this option for free, is at the expense of the other party, because usually when you buy a financial option, you pay a price. If now you go on a exchange that is trading option, for example, Talix is an exchange that we are also working within Bitfinex, and you want to buy a Bitcoin, a call option on Bitcoin, you will have to pay a pretty good price. I mean, now maybe $1,000 or something like this. So if we give it for free to one of the traders, basically it's like you take away value from the other party, and it's not nice. And specifically, how would that work? Let's say that we create the an atomic swap where we say, okay, we will exchange 1 Bitcoin for 30K. We can agree, we can prepare the transaction, and then one of the party just waits and see if the Bitcoin price goes above 30K, it will execute the swap. If it doesn't, it will just do nothing. I mean, depending on if he's buying or on which side of the trade it is. But yeah, you got the concept. And this is not only gives value to one party, but also create this incentive to just hold the trade until something happens, until let's see how the price goes, and then I will decide if I actually want to execute this trade or not. So this is something that is not nice to have, but unfortunately it's impossible to completely eliminate it, because there will always be one party that needs to do the last step to execute the swap. So like we prepare the Lightning transaction, we sign it, we prepare the path, we do everything, but there will be one of the two parties that needs to do the last step to make it happen. Or same if you do it on chain. If you do it on chain, we could create like PSBT, co-sign it, but then there will be one of the two parties that needs to do the last step, like either to the second signature usually. And this party can leverage this possibility to either trade or not trade, depending how the price goes. But yeah, it's not possible to solve it. If there is a question. Sorry, I don't hear you. If yeah. Yeah, so the question is for the register. Sorry, I need to repeat the question for the recording. The question is it a problem for stablecoin? This shouldn't be a problem, but only for fluctuating assets. But yeah, when you trade, you usually trade two assets that have different value and the change. I mean, yeah, if you are exchanging like, I don't know, USDT against USDC, maybe it's not a huge issue, even that they are still different assets and they have divergence on price. It's Silicon Valley banks close the account to USDC and USDC goes to 80 cents to the dollar. Then there is a disparity on price and there is this trading opportunity. So two assets, either they are exactly the same thing or there will always be fluctuating price. Can be low volatility, high volatility, but it will always be something. Again, we cannot completely eliminate this, but we can mitigate it. First of all, by using Lightning, we have a big advantage because the inputs on the blockchain, they are already confirmed. So neither party have the possibility to double spend the inputs to basically cancel the swap. So at least that cannot happen. So in this way, only one of the two parties can have the option. And in this case is the one that is that needs to give release the pre-image of the Lightning payment. Better only one. So if only one party has it instead of both of them, it's already better. So at least there is half the chance that the trade will be holded for the free option. This option is an expiration, so it will be valid only until the time lock of the HTLC expire. So it's not an option that is valid forever. So it will probably not be extremely valuable. So the HTLC expires in one block or like a couple of blocks, then you have an option that is valid for half an hour, something like this. It has a value, but it's not so big. And if we give this option to the party which has at least some reputation at stake, then the likelihood that he will leverage the option is reduced. So the idea is that we give this option to the market maker that is providing a service. He has very little incentive to use it because it's an option with very short expiration, just like roughly 30 minutes or like 1 hour, whatever it is. So it doesn't have this big economic incentive to actually hold the payment and wait. But on the other side, if he does it, it will ruin his reputation and people will stop trading with him. it's not something that like a web of trust that we can prove that he misbehaved, because it's not like the fact that he didn't do something is not something that you can truly formally prove to third parties. But still, it will be more like a social kind of reputation. Oh yeah, like if everybody knows that this market maker is terrible to trade with, people will just go to someone else. So yeah, this is the general idea. So yeah, we can give our first round of question. I don't know if there is the wait for the microphone. So yeah, then after this we will do the demo. But let's first go with the question. Microphone.
Sorry. And how can I know that that market maker is a terrible market maker or is a good market maker?
You cannot. You can only know it if he does it to you. But then you can
so it's
kind of
personal relationship. I cannot see its behavior with other counterparties.
Yeah, the idea is that if he does it, you complain on Twitter. I mean, something like this.
Could you charge a small fee to avoid this? So if you initiate a trade and you pay a small Satoshi fee, and then if you cancel the trade, you lose the fee.
Oh, well, I think that you cannot. If you cancel the trade, nothing really happens. So you cannot like enforce a punishment or something like this. Maybe you could add some complexity by putting something at stake, but probably like you cannot really prove what happened or not happened to third parties. So either there is some coordinator that looks at both of you and see what happens, and then like it triggers. It's like an arbitrator that see like if one of the two parties misbehaves. Yeah, it's something you can do, but yeah, it's something that you can build on top of it if you want. But it adds extra layer of interactivity and complexity and some level of trust to another service provider. Okay, yeah.
The Bitcoin that you swap, are they native Bitcoins or wrapped RGB?
Native Bitcoin. Yeah. These are native Bitcoin because they are bought on Bitcoin is like these are normal Bitcoin Lightning channels. So yeah, I mean you could also wrap Bitcoin if you want to, but probably not many people will want to use a wrap Bitcoin when you can use normal Bitcoins. So yeah, it could be bought, but more likely will be normal Bitcoins. There is a question. Okay. Yeah.
The information about the RGB transaction goes into the operator output of the Bitcoin or Lightning transaction. Is it possible to put it elsewhere in the future because of the possibility of recognizing RGB transaction from the other is not so nice?
Yeah, no, it's true. So with the operator output, you only see an hash, so you cannot really tell for sure that is an RGB transaction because it could be there are other protocols that also use operator. But yeah, actually, I didn't mention it because I didn't want to go into this complexity. But RGB supports two commitment schemes. One is with operator, which is what we're currently using in this Lightning node. But actually, RGB supports also commitment with Taproot. So you can basically create the operator output inside the Taproot tree. And in this way, it's just another Taproot output. The reason why we have two commitment schemes is that, yeah, the Taproot one is more cool, you have a bit more privacy, you save a few bytes, but there's much more complexity in the implementation. So it's nice to have also the operator option so we can build a solution quickly without having to deal with all the complexity of Taproot, because it's still Taproot is still quite young. It's not widely supported in Bitcoin in general. So for now, it's nice to have the operator option. Then in the future, maybe we will start also adopting Taproot to get the benefits that you can get from Taproot.
Yeah. You mentioned those steps that are taking place between the maker and the buyer. How is this communication enforced or done? Basically?
Well. Now what we're describing here is how to do the settlement. This communication can happen in any way you want. So probably like the first MVP of this will have simple API calls. So the market maker will expose a few endpoints where this can happen. But then you can also add like more fancy stuff like peer-to-peer communication with all punch or nostr or whatever you want. So it's agnostic to the communication, the two parties, or they can even exchange Telegram messages. I mean, whatever you want. The two parties just need to exchange this information one way or another. There is another question at the back.
How do you bridge some assets and make them RGB assets on the Lightning Network? And if you can do that by locking them elsewhere and then bridging them there, how does the increasing of supply happens, right, on an RGB asset? How does that happen? How do you increase the supply of a RGB asset? Can you? And if yes, how is this new supply recognized by the other, nodes?
Yeah, in RGB, what you have is you have the issuer that issue the assets to a first UTXO, and then there will be another UTXO that is defined in the issuance contract that has the right to do a secondary UTXO if we want to have that, or we can have an asset that doesn't allow to have a secondary UTXO. And then when this secondary, the UTXO that controls the right to do another issuance, when it is spent, people can see that a secondary issuance happened. Actually, the issuer could keep this amount that has been issuing the secondary issue private if he wants to, or it can be public, depending on what he wants to do. Regarding the bridges thing, you will do, if you want to bridge asset from other chains to RGB, you just do you just use all the bridging stuff that you already have between multiple chains. Like you lock asset on one side and you have them RGB. It can be more centralized, more decentralized if you add complexity. So it's nothing RGB specific. It can be any bridging protocol that you can come out with. See, there is another question.
In Lightning, in general, there's normally the problem of the liquidity to receive assets, to receive Bitcoin. So I imagine there is the same problem if you have to receive a tether in exchange of Bitcoin you're trying to sell.
Yeah, absolutely. Like you have the same liquidity problem that you have with Bitcoin. Nothing changed. So you still need to have inbound liquidity in USDT. Ideally, you will have, for example, if the maker wants to be a good service provider, he can open a channel with you. Open a channel with him in Bitcoin, and will automatically open a channel with you in USDT, so you can immediately trade. Or you can have professional LSPs that do it for you. Can be many solutions. Yeah,
I have a follow-up question about the issuer that can keep the right to issue new supply. You said that if he does, he can choose to make it privately, which means we cannot have a full idea of the whole supply that's circulating. Is that correct? And if yes, does that mean that we have to make sure that he renounces that right and then probably whitelist new RGB tokens as being part of the same asset, do RGB token 1, RGB token 2. So every time he renounces that right, we know at least that these two supply combine into one asset. Is that something we should do in order to... Because if we don't do that and we only have one asset, we have to trust the issuer that the supply didn't change or something like that?
Well, in a way, you anyway need to trust the issuers to some degree, because as long as they are centralized assets like Tether, so the issuer can virtually inflate the supply in other ways, maybe by not having enough collateral for whatever that is. So I think to trust the issuer with this is it doesn't change the security assumption of a stable coin or any other centralized token. So I think the issuer has an incentive to be transparent. Otherwise, you could just steal the collateral that is not on RGB somewhere else. There are many other ways that the issuer can scam you if he really wants to. So I think, of course, it's a problem, but it's not a problem to introduce extra security assumption that what you already have. Okay, are we done with the questions? So we can finally move with the demo. So we will now have a demonstrations of how this works. So we have a short video of the demo of the swapping protocol. So this is still very experimental. You will not find this feature in the Lightning node that it's on our GitHub, even if we will introduce it hopefully soon. In the next few weeks, if we are lucky. But so the setup that we have here, we have two Lightning nodes. These are two terminals with one Lightning node on one side and another Lightning node on the other. They already have some Bitcoins. They already have some UTXOs where they can allocate assets. And so the first thing that will happen is that one of the of the two nodes will start doing the issuance. Here this is not an error; it's just to get the help message. And then it will issue an asset. Now we just set like a 1,000 USDT or whatever we want to issue. And so the first node has issued some asset. And so now it will want to open a channel. It will open a channel with the other node, and we already have the node ID available on the other side. So these two nodes already exchanges some information about their node ID. So we open the color channel, and we provide the public key counterparty with this endpoint. We say how many Satoshi we want to push, but this is like a mostly constant amount. Then the channel amount, the RGB ID of the contract, and how many RGB assets we want to push. The recording there was a small error. Now it's done again, and now the channel is opening. Channel initiation is happening, and funding. It went all went good. So funding is completed. Now now we can see the channel on both sides, and some blocks needs to be mined. So now the blocks have been mined. This was like a reg test environment, of course, and the channel is ready to be used. So we do the same on the other side, because we created first. First, we open a channel denominated in this USDT, and now we need a channel denominated in Bitcoin from the other side, so we can do the swap. So now we have a channel also in Bitcoin. We mine a few blocks to have it confirmed. And now everything is ready. Now we clean the terminal, and now we will see how the swap is executed. This is just to get the help message. So now the market maker make first proposal. So it says that how many assets you want to exchange. In this case, 10. Which RGB asset? The RGB asset ID. What he wants to do? He wants to buy. How long will this offer? For how long this offer will be valid? So 1 hour. 30 seconds, and how many assets you want to, and what is the price? So in this case, is expressed in millisatoshi. So it's like 500 satoshi, if I can read correctly. So now the output of this command is that you get a string that you can pass to the taker. So on this left we have the maker, on the right we have the maker. So now the taker will import this string in his own has imported the string into his own node, and he made this whitelisting of the trade. So then the taker say, okay, I did the whitelisting, please move forward, and the maker can execute the swap, now the trade just now the trade just need to happen, and confirm now. Sorry, it just closed the video by itself, but everything was concluded, was settled. Any question regarding this? But I guess no, because we already covered the theoretical part. So now for the last part of this workshop, Gabriele will take the stage and will tell us about what is working on for the first user interface for all of this.
Thanks, Federico. Hi, everyone. I'm here to present KaleidoSwap, which is a solution to enable trustless trading of digital assets on Lightning Network. I'm Gabriele. I come as a full-time job, I run a market-making company, so I come from a trading background, but today I'm here as a contributor of KaleidoSwap. Before diving into the presentation, a few disclaimers. KaleidoSwap is a fruit of effort of several contributors, and it will be released as a desktop application, open source desktop application during the first quarter of 2024. All right. As I was saying, I come from a 3D background, and when you trade a lot, the main risk you want to hedge to manage is the counterparty risk. So the behavior of the other counterparty that is trading with you. So when it comes to peer-to-peer trading, that's much more important. That's why we wanted to develop a solution that enables trustless trading between two parties. Why we decided to do that on Bitcoin? Because when it comes to trustless settlement and decentralized trading, the decentralized part is very important. So you want to choose the best settlement layer you can have. For sure, also you want to have a programmability layer, which is actually RGB, and then you want to, if it's possible, like with the Lightning Network, you want to mitigate and decrease the settlement cost you can have when trading. And so on top of all this stack, you have Kaleidoswap as an application, again, on top of the stack presented before. Decentralized trading is already something now. We already heard about decentralized finance, but just to understand a little bit what are the difference between centralized finance and decentralized finance. 100% centralized finance is subjected to regulation, so regulator can enforce every policy they want. And then you have an high counterparty risk, especially in the current digital asset, crypto asset capital market setup when everyone is trusting a lot exchanges. But for sure you have better pricing because the cost of quoting prices in an order book is less than streaming prices on chain on EVM like blockchains. And then when it comes to centralized finance, you also have fiat support. You commonly have fiat support. Whereas in decentralized finance, it's a permissionless ways to trade, and this comes because you own your key, so you are able to own your asset. That's why it's permissionless, and because there are contracts that allows trustless settlement. I mean, you are trusting the contract that is going to execute the transaction atomically, and also there is no KYC availability. So what we understand is that when it comes to pricing and price discovery, centralized finance delivers much better results. Whereas when it comes to settlement, using Bitcoin as a layer, or a blockchain, it's much better because you can have trustless settlement. Again, there is already decentralized finance, especially on Ethereum virtual machine compatible blockchains, but decentralized finance has few issues, few challenges. For example, when it comes to privacy, it's really tough to trade, with a certain degree of privacy. There are solutions like Nansen, especially for Ethereum, that allows the tracking and the monitoring of every wallet and what every trader is doing. Whereas when it comes to liquidity, it's super difficult to bootstrap liquidity in a pool, especially for the pricing model that common decentralized exchange on Ethereum has, so the automated market maker model, and it's pretty capital inefficient, right? When it comes to price, instead, you always face high slippage because of the lack of liquidity, and there is lack of liquidity because there is a huge impermanent loss risk for the passive liquidity providers that cannot keep hedging and adjust their liquidity. And lastly, you have MEV, which it's actually the front-running risk, because since everyone can see what you're doing on the blockchain, everyone can front-run you, just paying an higher fee to attack your transaction and front-run you. When it comes to transaction cost, actually, if you keep trading on layer one, let's call it like this, you face huge and high transaction cost. Whereas when it comes to, again, settlement, you also risk the fact that since it's not privacy aware trading, you risk the fact that someone can censor your transaction, especially on EVM like blockchains. And lastly, I think everyone knows that there were a lot of rug pull and exploits on DeFi on EVM-like blockchains, both because of the smart contract risk, since the funds the liquidity is in the smart contract, in the liquidity pool, and also economic exploit because of the pricing logic embedded directly in the smart contract. With DeFi on top of Bitcoin, we can actually address few problems. So when it comes to privacy, as Federico was explaining, it can be much better privacy, preserve better the privacy, since you can trade on Lightning Network, you just have the first transaction on chain. For sure, they can be heuristic on the transaction, the channel opening transaction, but it's much better when it comes to trading, especially with RGB assets as counter assets. And when it comes to liquidity, everyone can provide the liquidity. So in the model Federico was explaining, everyone can become a market maker. It just needs to connect to an endpoint and start streaming prices. Second of all, you can have, since the pricing is not on chain compared to Ethereum, you can have much better pricing, right? So again, the request for quotation model that Federico was explaining, so the fact that I'm a trader, I'm gonna ask for a quotation, and then it's frozen for a certain type of seconds, allows the trader to understand beforehand the price is going to execute, at what price is going to execute, right? And so there is no slippage. And there is no risk of front running, because the transaction is not in the mempool, and people cannot see that, right? So that the transaction cannot be front run, and then there is definitely a better price discovery mechanism. When it comes to cost, for sure you have cost when you're opening a channels, right? But then if two parties keep trading all together, against each other, this cost is really minimum. And also, Lightning Network fees are mostly deterministic. Even if you're routing, you can have a decent understanding of how much you're going to spend, whereas in EVM like blockchain is not the case. And lastly, again, since it's privacy aware, it's much difficult to be censored, right? Lastly, when it comes to exploits, since the liquidity is not in the smart contract, it's much more difficult to be exploited, both on the smart contract side on the liquidity pool and from an economic side, because the pricing is not made again by the smart contract logic. All right. So this is the way we are going to deliver those results. This is Kaleidoswap. Is actually the desktop app that I was mentioned. What will enable it is actually again trustless trading, which is our focus. So for now, Kaleidoswap is a wallet. So basically, you onboard, you fund your on-chain address, and then you can open channels. What allows, again, is no counterparty risk when you're trading. And that's, just that is a great result. Plus, no KYC, which, at least in the beginning. And then low transaction cost when it comes to settlement. You can keep trading and, settle with the clients without having, or with the counterparties without having a huge transaction cost. Then pseudonymity. Plus, you can have a model where it's a request for quotation based, so you can freeze the price and have all the advantages mentioned beforehand. And then you can support multi-assets, meaning you can trade the RGB asset against another RGB asset or against Bitcoin, etc. But the most important part, again, it's that you can divide the pricing and having a great pricing off-chain and a settlement on-chain. So leveraging the benefit on both centralized finance and, let's call it, decentralized finance, right? So when it comes to pricing, what you need to do is basically connect with a market maker. So that's Kaleidoswap. The market maker needs to connect to some endpoints of the app, and then can start streaming prices and answer to the request for quotation of the takers. Anyone can be connected as a, please. Yeah.
The process of streaming prices and quotations is free, right? It's just the settlement that you will basically have to pay.
Yeah. The process is free. So anyone can be a market maker, just needs to integrate the API and start replying to the request for quotation. And again, can quote a price with an RFQ model and decide how long he wants to freeze the quotation, right? When it comes to settlement, you can have either a direct channel with a market maker, right? And the model is the trader is going to open a channel with the market maker, and the market maker is going to open on the fly a channel for the other asset with the client, with the taker. This because, again, to avoid the inbound liquidity problem for the clients, and in addition to use it the first transaction as an anti-spam for the market maker. Otherwise, everyone would open a channel with the market maker, and the market maker would have really low capital efficiency because it needs to allocate capital every time, right? And so either you open a direct channel or you support a Lightning service provider that improve the connectivity between parties and allows routing, different routing, so you don't need a direct channel open with the counterparty. That's so again, pricing super efficient thanks to this model, but trustless settlement and also with a low cost, right? That's what we want to achieve. But just focus a little bit on the settlement with Lightning Network. So again, direct channels or routing among different channels. But again, you need two different type of channels. And let's say the RGB assets one, it's much more capital efficient because you need few Satoshi just to open, but you can transact RGB token that represents higher value, basically, right? And then you have this atomic settlement, meaning that if the one of the party doesn't execute what is promising, the transaction is not going to be confirmed, and this is what gives you the trustless side, low cost and capital efficiency when it comes to trading with each other. It's instant, right? It's peer-to-peer, meaning that anyone can be a market maker and anyone can stream prices or trade there. So this is super important. And again, pseudonym, even the settlement. All right, now we understood a little bit how it works, but just focus. I would love to focus on the use case that we actually see, right? So the use case assume that someone is going to issue either a bridge Tether or any bridged stablecoin on RGB, or maybe directly Tether is going to issue assets on RGB, right? And so what is going to happen is that someone has maybe Bitcoin and wants to sell Bitcoin against Tether without having no one watching, without not doing a KYC, and he can download the desktop application, run the node, connect with the market maker. So let me show here. As you can see, there are several market makers where you can connect with them, right? And for sure there will be a market maker by default, but you will be able to connect with everyone, right? And how you connect is basically this interface. So you need to put the identification of the other channel, the other peer, you can connect with them, right? So once you are connected with the market maker, let's assume that there are also professional market makers running the Kaleidoswap solution. You're going to ask for a price. You're going to fund your wallet, ask for a price to the market maker. The market maker is going to answer. You are going to open a channel with the market maker in Bitcoin because you want to sell Bitcoin. The market maker is going to open a channel with you on RGB Tether, for example, and then the swap is going to happen, right? But for sure, it is possible also to do that. Not against a professional market maker, and it's likely to it's reasonable to think that if you are a professional market maker, you have the infrastructure to handle all the liquidity and channel challenges related to Lightning Network, both for Bitcoin and for the other asset, right? Whereas if you are, let's say, another user or someone that wants to be on the other side of the trade, it's much difficult to have all the infrastructure to handle both Bitcoin Lightning channel and RGB Lightning channels, right? So it's reasonable to assume that Lightning service provider will start providing these services both for the Bitcoin liquidity and for Tether RGB liquidity, and so the connectivity would be much better. And also the thing that I personally like a lot of this stuff is that something like at some point regulators will go against the professional market maker quoting prices, and so the professional market maker should enforce some type of KYC or anti-money laundering on the clients who is trading with, right? So what you're going to have, in my opinion, is that you're going to have great prices streamed by professional market makers, but you need to have the KYC to trade there, and the benefit you will have is trading on Lightning Network and trustless settlement, and then you will have a little bit worse prices, but without KYC with other peers trading on the solution, right? And the benefit, we understood the benefit and the advantages of the business case, but in general, the reason why we are doing this and we are working on this, because we believe that this project can really benefit a lot the Lightning Network ecosystem. First of all, because having a stable coin on top of Lightning, will result in several advantages. Basically, you will be able to settle with Tether, so with, let's say, USD dollar everywhere, basically in an instant way and with almost zero cost, right? That's just that, it's huge, right? And on the other hand, Bitcoin Tether is the most traded pair in the crypto industry. If we bring this volume on Lightning Network won't be just the infrastructure to pay, but it will be also the infrastructure to trade. And so a lot of liquidity, major investments, a lot of Lightning service provider, the infrastructure will be much better. So that's also something that, the reason why we're doing that is also, contributing to the Lightning Network ecosystem. So just a quick recap again. KaleidoSwap is a wallet. It's going to be released as an open source desktop application, the first version, in first quarter 2024. In order to have a business case for that, we definitely need a stable coin on Lightning Network, because you need to trade at least 2 assets to have trading. And we believe that stable coin against Bitcoin trading on Lightning Network could definitely benefit all the Lightning Network ecosystem. Again, I'm Gabriele. If you want to speak with me about KaleidoSwap, I'm going to be around. And again, we want to allow trustless trading on Lightning Network. Thanks for the attention.